With this presentation, we're going to figure out how to find the axis of symmetry and the vertex from both standard form and vertex form of quadratic equations. To determine the axis of symmetry from a standard form equation, there's a really simple equation for it. It says x is equal to negative b over 2a, where b is the coefficient of the x term and a is the coefficient of the x squared term. So in this equation, our b term is negative 4, and our a term is not visible, which means it's an understood 1. So the formula for our axis of symmetry here would be x equals negative 4 over 2 times 1. Well, of course, negative 4 is simply 4 over 2. So 4 over 2 is equal to 2. So this means that our axis of symmetry is on the line where x is equal to 2. That would be where the parabola is equal halves. To find the full vertex, we know the axis of symmetry goes through the vertex. So this is the x value for the vertex. So I could go ahead and write it as part of an ordered pair for the vertex. Now to get the y value, I would simply need to take the equation, the x squared minus 4x minus 5, which is equal to y, and I will substitute in the value of 2 for x. So that would make it y equals 2 squared minus 4 times 2 minus 5. And then by simplifying this, I can then find the y value for the vertex. So y equals 4 minus 8 minus 5, or y equals negative 4 minus 5, y equals negative 9. So our vertex is at 2, negative 9. As long as you know a value of x, you can simply substitute it in to find the corresponding value of y. So for us, that means that x was 2, and therefore our vertex is at 2, negative 9. Remember, you can pause at any time to attempt to do some on your own before seeing the work that I've done. I feel like that would be really beneficial to you. So let's start with the formula for the axis of symmetry. X is equal to negative b over 2a. In this case, our b value is negative 12 and our a value is 2. So our formula will be negative 12 over 2 times 2. That simplifies to 12 over 4, or 3. So now we know the axis of symmetry is at x equals 3. We also would then know the x value for the vertex. So I can go ahead for my vertex in the ordered pair, put 3 for x, and then like we did a while ago, I'm going to take the equation, y equals 2x squared minus 12x plus 14. I'm going to substitute in 3 for x. So y equals 2 times 3 squared minus 12 times 3 plus 14. This simplifies to 2 times 9 minus 36 plus 14. Continuing to simplify would be 18 minus 36 plus 14. Negative 18 plus 14. That makes y negative 4. So this equation has a vertex at 3, negative 4, and an axis of symmetry at x equals 3. So this is our third and final example from standard form. If you feel like you don't need it, feel free to skim past it. Let's start with that x equals negative b over 2a again. This is that formula for the axis of symmetry. Then we can say x equals, in this case, b is 7, so we would have negative, and then b is 7, and a, there's not a number there, so that makes it a 1, so 2 times 1. This would be negative 7 over 2, or negative 3.5 if you wanted to make it a decimal. I personally would leave it as negative 7 halves, so I'm going to say x equals negative 7 halves. Now, since x is not an integer value, that will make the computation a little more challenging. For finding the vertex. So remember, this is our axis of symmetry. And the axis of symmetry is on the vertex. So now we know for the vertex, the x value is -7/2. So if I take the equation y equals x squared plus 7x plus 10, then I can replace or substitute 7/2, -7/2, in for x. And then simplify. So -7/2 squared would be 49/4. 7 times -7/2 would be -49/2, and then plus 10. So to get a common denominator there would be, the common denominator would be 4. So we would have 49/4 minus 98/4 plus 10. Ooh, I'm going to have to write smaller. So this would be -49/4 plus 10 to go to a 4 would be 40/4. So -49/4 plus 40/4 would be -9/4 for our y value. So you can see that the math on that one's a little more challenging. Of course, if you have a calculator, you could do the decimal forms, or if you're great with fractions, you can just simply use the fractions. Now, what's great about vertex form for quadratics is that, as the name implies, the vertex is actually part of this equation. So when we're looking at the form f of x is equal to a times x minus h to the power of 2 plus k, then your vertex is actually hk. So whatever the value of h is and k, that is our vertex. And then if we know the vertex, we know the axis of symmetry goes through it, and it has to be that x value, that vertical line. Now the tricky part of this is that the formula is subtraction on the h. So we'll have to make sure that it is written as subtraction so we can see what the real h is. So if we're looking here at this example, you can see that it is not written as subtraction, it's written as addition. That's a simple fix. If we're adding, then we can reverse that to subtracting a negative, because subtracting a negative is the same thing as adding a positive. Now it is in the exact same format as our formula, and so our h value is -2, and our k value, which was addition, now this is subtraction here, and we could have rewritten it as plus. Let me just do that for prosperity. So we could write it as plus -5. So now it truly does match even on the k. That means k is -5. Seeing the subtraction and keeping it on k doesn't tend to be the bigger issue. It's that subtraction on h that causes more problems. But now we know that the vertex is at -2, -5. And if that's where our vertex is, then our axis of symmetry has to be through the vertex where x is -2. So this one is a little simpler than standard form because it does include that vertex. So let's try one. So here we can see that in this case, unlike the last one, we do have a value of a, and it is already subtraction. So if we wanted to change this part to be addition, we could. So we could rewrite it as 2 times x minus 3 squared plus, and then k would be -4. So now we know that h is a positive 3 because it's -3, so the minus was part of the formula, and k is -4. That makes our vertex at 3, -4. And then if we know the vertex, again, we know the axis of symmetry has to run through it, so our vertex would be at x equals 3. Now this is actually the vertex form of the exact same equation we did second with standard form. So we get the same answer, 3, -4, whether we're doing it from standard form or from vertex form. So that's how you found vertex and axis of symmetry using the equations.